First That Rock here with Simpson Math. Let's talk about the variance of a game. We use sigma squared. This is a lowercase Greek letter sigma. Sigma. The uppercase is this symbol, and the lowercase is this symbol. We use sigma squared to equal a population variance or the variance of a game. Okay. And the variance of a game is the summation, or that's capital sigma, Greek letters sigma in the capital form. But anyway, it means summation, means add up. It's the summation of the products of the probabilities and the squared deviations from the game's mean. Now, what is standard? We'll do an example of that in a minute. What is standard deviation of a game? Well, it's simply the square root of sigma squared. So it's the square root of the variance. So it's the square root of the variance gives you the sigma. And so we use, standard deviation. So we use SD a lot for standard deviation, but we also use sigma for population standard deviation or for the standard deviation for a game, okay? So there's the symbols and there's the formula. Okay, so remember this game. We got a bunch of players to play it and we figured out that the expected value was 3. Okay, and now what we want to do, now that we know the expected value is 3, we want to find the variance in the standard deviation. So how do I get that? Well, list all the x values. Well, in that game, remember, if you didn't hit either one of the baskets, if the ball hit and bounced out, you got to shoot again. But if the ball came in and landed in there, you got 10 points. Or if the ball came and landed in this bigger basket, well, the game was over and you got 0 points, okay? So that's how the game was played. So you could shoot again until you got either 0 points or 10 points. So there's only 2 things that could happen. You could get 0 points or 10 points, okay? Now, we're supposed to go the x value minus the mean. The mean is 3. So 0 minus 3 is equal to negative 3. So the first deviation is negative 3. The other deviation is 0 minus 10. What am I saying? 10. That's totally wrong. Totally wrong. What the heck? You're supposed to go the x value minus mu. So it's 10 minus 3, which is 7. Okay, so the deviations are negative 3 and 7. Since we expect players to, on average, to get 3 points, when somebody gets 0, well, they're 3 points below the average, and when they get 10, they're 7 points above the average. Then you square these numbers. So 3 squared is 9, and 7 squared is 49. And remember, a negative times a negative is a positive. These are always positives. That's in fact why we square them. And now you multiply them by the probability. So by their probability. So 9 gets multiplied by its probability. Well, what was that? Well, we got to go back and we have to remember that 7 out of our 10 people in our sample got 0. So the probability of 0 is 7/10. Okay? And then the 49 gets multiplied by the associated probability of 10. Well, 3 out of 10 people got 10, so the probability, the empirical probability based on our experiment was 3 out of 10 that somebody would get 10 points. So now what we do is we add this up. Well, let's get these numbers. 9 times 7 is, oh my gosh, why do I have a 7? This is terrible. Well, let's see. Is it, 7 times 10 is 70. So I'll back up a 7, it's 63 tenths, okay. See, now 3 times 50 is 150. So you just back off 3 from there because you're 1 less each time. So that's 147 over 10. When you go 49 times 3 tenths, you get 147 over 10. So now what I'm supposed to do is I'm supposed to add that up. So the variance is equal to this plus this. 63 tenths plus 147 tenths. Well, 60 and 140 is 200, and then the 7 and 3 make a 10, so that's 210 tenths, which, you knock off the zeros, and you have 21. So the variance is 21. What's the standard deviation? Well, the standard deviation is the square root of 21. And what is that about? Well, just remind yourself the square root of 16 is 4, and the square root of 25 is 5. So it's close to 5-ish, I don't know, 4.7-ish. Who knows? But, that's a good enough estimate since we don't use calculators. And if we needed this to be precise, well, the engineer that needs this to be precise could pick up a calculator. You could just report that to them. And that's how you find the standard deviation of a game. Math made simple. Simpson Math.